In this video, we'll be covering the basic concepts of data warehouse and data lake. Data warehouse is a terminology which has been in use from the 1970s. It's a pretty popular terminology. Even though you guys are not working on a data related projects, definitely you guys would have heard about the terminology data warehouse, data warehousing concepts and everything. On the other hand, data lake is something pretty new age. So that's where the industry is moving towards. Industry is moving towards creating data lakes instead of data warehouses. That's the future. So in order to appreciate what data lake can do, and then what are the advantages and of using a data lake over a data warehouse, we need to understand both sides of the coin. So we'll try to explain some basic concepts of data warehouse. Once we make you aware of what a data warehouse is, then we'll move on to some data lake concepts. So depending on where you end up, you may have to work on projects in which you have to support a data warehouse environment, or you may be developing a new project from scratch where you have to build up a data lake. Or sometimes you can also help customers to transition from a data warehouse into a data lake, right? So even if you want to work on any of these projects defined, you have to be aware of both concepts of data warehouse and data lake so that you can apply your best possible solutions, right? So why do we need data warehouse and data lake, right? Because we have data all over, right? If you look at it, everything, it's now, even in the recent times, data is getting generated at a very faster pace. That's why we are moving on to something big data and everything, right? So we will try to understand why there is a need for a data warehouse or a data lake in first place, right? So data is all over the place. So even though the data is all over the place, when you want to find, I can't find the data I need. Say for example, you want to retrieve some data, you want to take a look at a certain aspect of a business use case, then if the data is scattered all over the network, right, so you really don't know where to find your data. It's very difficult, right? And then another thing is I can't get the data I need, right? So you being a business analyst or a data analyst, you want to get hold of a certain piece of information in order to make a business decision, right? So but you don't have an access to retrieve the data, you don't have the expertise to bring the data from certain application. So in that case you will be looking for an expert to get the data, right? And then even though you get the data, sometimes you don't understand, I can't understand the data I found because it's not the format which it can make sense to you, right? So the data is not really documented well, or it's not in the certain format, an understandable format, or it's not something in a queryable format, right? So if that's the case, then it's of no use. So you can't understand the data, it's of no use. And then once you get everything but you cannot use the data you found, basically you have to apply some transformations, you have to convert from one form to another. So all those complexities are involved when you want to perform some kind of data analysis, right? So collecting the data and having access to the data is just one part of the problem. So if you don't really find ways to transform the data in the way you want, and then make it in a presentable format where you can run reports or derive insights, it's of no use, right? So you have to bring all the data into a certain data model, into a certain structure where you can run queries to analyze something, or you can run some reports or visualization dashboards on top of it. So you need to bring it in a certain way. So for that, you will need to take the help of the experts. So there are a lot of people involved, starting from data analysts who can take a look at the initial data and perform some data mapping on how to get into a data warehousing format data model. And then you need ETL developers who are experts who can work with the data analysts to identify the data sources and then bring them into a certain staging area and then apply the transformations based on the business requirements given by the business analysts, and then push it into the presentation layer where the reporting will be taken care, right? So there are a lot of roles involved in order to make the data a valuable source, right? That's the reason we call the data is the new oil. That's the new terminology coined. So basically, if you look at oil in its raw form, right, it's of not of much use and it's not really valuable when the oil is in raw form. But when you refine the oil, then it produces a lot of value, right? That's the same case with respect to data. So having access to the data in the raw form, it's not really going to be worth it. So if you refine the data in such a way that you can access it to derive some insights, you are able to provide some visualizations and then aggregations, dashboards, reports in order to influence your business decisions to perform better, then it's going to be really worth it, right? So data is the most valuable resource. If you guys have noticed, data is actually driving many part of the decisions in the world across, right? In any industry, if you take, rather than focusing on their operational environment, there is an additional revenue always involved with respect to the data they get collected, because on top of running their operational systems and generating revenue, they'll be able to consolidate the data, and if they're able to present it to external third party vendor who can provide an insight, then it's going to be an additional revenue for any company. And there are lots of companies whose primary business is data itself, right? So people are collecting data all across the world in order to derive insights. So it's a very, very valuable resource nowadays. So once you get the data, which is a scattered data, it can be in a file form or it can be in a different format form. You have to bring it into something called a database, right? First thing, like the collection of databases is what we call as data warehouse. So first you need a database. Database is nothing but a bunch of rows and columns in a certain format. So even an Excel sheet with a certain amount of information is also a database, right? So we need to understand what is a database and a data warehouse. So if you look at it, database is just an organized collection of data, usually tied to a single application, such as ticketing system. Say, for example, you're working on a company which has like a lot of different departments, right? So each department will have its own database. So in this case, there is a ticketing system, then there will be a ticketing database. If there is an accounting team, there will be an accounting database. So individual business areas will have their own database where the day-to-day operation data is getting collected and stored into a database. So primarily in a database, there will be inserts and writes happening. So because anytime a transaction happens, you want to make an entry into your database. Anytime, sometime somebody updates some information, then you have to make an entry into the database and update the record. So it's going to deal with individual records at a time. So even very small number of records will be updated in the same time, right? And then data is also normalized to allow quick response times. If you guys are aware of the concept called normalization, there are different levels of normalization in order to reduce redundancy and also speed up your update process. The data is stored in the normalized form in a database so that the transactions can make the updates pretty quick. So meaning databases are designed to be write efficient, right? And also databases mostly will have the current or point in time data, meaning what is the latest update is what you can see there. Once you update the record, you really don't have access to understand what was the previous state of the record, right? So in databases, you really update the record and then you just proceed. So you really don't store the history of the transaction. Say, for example, a customer comes and updates a phone number or address, right? So if you go to the database, operational database, you will only see the latest phone number or the latest address of the customer at that point. So you don't have any access to any of the historical data. What was the previous address of the customer? You don't know about that. And mainly online transactional processing. So that's what we said, right? Anytime a transaction happens, you have to update a bunch of tables in the background in order to get the data in sync between certain tables. You'll be updating certain records. So it's more of a write efficient online transactional processing database. And then it will provide you a detailed relational view. So basically, if you update a customer table, it might be related to another, triggering another update to the customer address table, and then any other demographic information will all be updated. So it will be in a relational view of a customer. You can find it in a database. And then it is also designed for many concurrent transactions, because in an operational environment, there will be a lot of concurrent updates or transactions happening in real time. So your database has to be designed in such a way that it supports efficient writes, right? That is with respect to a database. So this is completely an operational environment, right? So now we are primarily focusing on what is something called a data warehouse. Now let's see what is a data warehouse. So data warehouse, on the other hand, is a central repository of integrated data from one or more sources, right? If you look at a database, we talked about different departments, right? So ticketing system, accounting application, or some kind of support application, or whatever it is, separate databases. So in data warehouse, we have to bring them together into a centralized repository so that we can get a holistic view of your entire business. So it usually stores the data from number of applications. So data from all the applications flow into the data warehouse as a centralized repository storage, right? And the primary operations that are performed on a data warehouse is going to be read or retrieve data. So you'll be running analytical queries on a data warehousing environment, which will actually be designed to be read efficient so that you can get quick response times on your queries you're executing, right? So the design itself will completely different from a database, operational database environment. So if you look at it, an operational database, we have tables in the normalized form, right? So mostly data warehouse will have denormalized so that you can have more information stored about a certain record into a single row instead of joining to multiple tables. So we'll try to denormalize the rows and then try to reduce the number of joins. And then you'll build a fact dimension model where you'll have a fact in the center of the data warehouse, and then you'll have multiple dimensions around them. That's how you design a data warehouse, because you want to make it read efficient so that you can get quick response for your queries from the business layer. And then the data warehouse has the historical data. So the data warehouse, if you're building a data warehouse, you have to maintain history and retain history of your application. In the previous example, we saw like when a customer is updating a address or a phone number, right? So in a data warehouse, you should keep track of all the previous addresses the customer stayed in and what are the previous phone numbers the customer used or whatever. That's just an example. Similarly, if you are designing any other solution for a data warehouse, you need to store the historical data. And then the data warehouse is primarily used for online analytical processing, right? So that's the difference between online transactional processing and online analytical processing. Online transactional processing is write efficient, and then multiple concurrent transactions will take place, which will touch only small amounts of data. On the other hand, in OLAP, online analytical processing, you will be designing your application to be read efficient, and then whenever you execute a query, it's going to churn up a lot of data in the background, right? And then this data warehouse will provide you with a summarized multi-dimensional view. Mostly in data warehouse environment, since you're dealing with bigger amounts of data, we'll be aggregating the result sets, and then you will be running queries to find out like what was my sales last week, or like what was my performance of this particular product over the past 6 months. So it'll be like summarizing your records and getting you a multi-dimensional view in a data warehouse, right? And then you cannot perform a large amount of concurrent transactions in a data warehouse. So this has to be like, ad hoc queries and reporting, and then dashboarding is going to be taken care in data warehouse. So it's not really designed for large amount of concurrent transactions, right? So when you design a database, you have to determine whether you are designing a database for an operational environment or you are designing a data warehouse environment. Depending on that, you have to follow a different set of design considerations and principles for the respective operational data store and the data warehouse. It's pretty critical to understand the difference between these two types of databases, because that's going to be making the primary difference between working on a typical application. You may be working on an operational application. Everybody will be working on an application where you will take care of that application business logic, day-to-day operations and everything. As a data, when you move into the data side of it, you will be working with all the applications data into a centralized repository, and you have to design your application to be read efficient, right? So it's very critical to understand the difference between an operational data store and the data warehouse. So why do you need a data warehouse, right? So what's a data warehouse? So a data warehouse is a central repository of information that can be analyzed to make better informed decisions. So what mean by informed decisions, right? As a business has to make some decision on a certain product, they have to be having some data to back it up, right? They cannot randomly go and make some decisions which will impact $1 million of revenue or whatever. So when they back it up with the data and the trend of the application, they'll be able to make some informed decisions. That's why the data warehouse will provide. That's what data warehouse is providing with you, a centralized repository of collection of all the data. So the data will flow into the data warehouse from transactional systems, relational databases, and other sources, typically on a regular cadence. So basically, we talked about the operational data stores, right? So you need to get the data flow from the operational data stores into your data warehouse environment, and then you will be applying all your logic on top of it, because you don't want to interfere with your regular day-to-day business where your operational databases are supporting, right? So basically that's why you create an ETL flow or data flow where you collect all the data from your operational system into your data warehouse application, and then you have to schedule kind of a batch process or something so that you can regularly update your data from the operational source into your data warehouse. From there you can run your reports, right? So who is going to use the data warehouse? Business analysts, data scientists, and decision makers access the data through business intelligence tools, SQL clients, and other analytical applications, right? Depending on who your end user is. For example, if it is a CEO or a CEO of the company and they want to find out performance of a product which they have newly launched in the past 3 months, then they'll be coming to a visualization. They want to see, they don't want to come and write the SQL query to understand the data. So they want to see the real value of the data into some visualization dashboards where they can quickly click some buttons and then derive some insights out of it. They don't have much time to go and spend a lot of time into the data by running the queries and all, right? So for those kind of end users, there will be visualization tools where they can just look at a picture or a dashboard and then get an insight about how the product has performed. Or if you are a business intelligence analyst, you want to get into a deeper level and then slice and dice your data into a get individual row level and find out something, then you will be running some using a SQL client to connect to your data warehouse and run some SQL queries and everything to derive some insights. Or if you are data analyst, you want to run a report, you can go and like dump a particular table into an Excel sheet and then you can work on it. So there are various end users for a data warehouse who can take advantage of the data that is stored in a data warehouse. So why do you need a data warehouse? Again, it's a consolidation of information resources, and then there will be an improved query performance when you churn a bigger amount of bigger data sets in the background. And then you have a separate research and decision support function from operational systems, because you don't want to interfere with your operational system and then impact your production performance of a real-time application. So you always have to have a separate area where you can research and run huge queries, and then you can run your decision support systems on top of it and then get some insights out of it. And then it also serves as a foundation for data mining, data visualization, and advanced reporting and OLAP tools. If you want to employ any number of tools, nowadays there are a lot of effective, efficient business intelligence tools available in the market. So if you want to host a business intelligence tool on top of your data and derive insights and interactive dashboards, you have to go to a data warehouse and get that done. So what's the usage? Like what type of questions a data warehouse can answer? It's pretty important to understand this, like because all the time and money, effort the companies are spending on a data warehousing environment, right, has to provide some value for the business. So what's the value of like maintaining a data warehouse and hosting a data warehouse platform and spending money on it? So basically it boils down to the data analytics point of it, right? So how can I get the value out of my data warehouse? It can answer a bunch of questions. These are the questions which will derive the requirements of a project. So the business will come and say, like, ask these questions, and then the business analyst will translate these questions into business requirements, and then he's going to hand it over to the technical team, who is going behind and then working on the data that is required to support the questions that is asked by the business. That's how a project is working, right? So which are our highest and lowest margin customers? So they have to get, if they get the insight about who are the highest margin customers, then what they can do is they can make sure they don't lose their business and then keep them as your customers, so that they are contributing highly for your income. And who are your lowest margin customers? If you identify those type of customers, you can go and work with them and then get some extra care for those customers to earn their business more, and then you can try to improvise your profit margin with respect to your low margin customers, so that you can do well in your business, right? And then who are my customers and what products they are buying? So basically you have to figure out, if you have data about the age group of the customers who is buying your product, right? And then you can determine, like, okay, what are the products youngsters are buying, like 20 to 30 years old people, what kind of products they like from a company. Then what kind of products are the elders are buying from a company. You can, if you get the insights out of it, right, you can provide your marketing, and depending on the population of the area where you are selling your product, you can derive a lot of insights about, if you get more about the customers, then you can just bring in some new offers We can to improvise the business, then you can do any type of decisions in order to support the customer requirement in that particular area, right? And then which customers are most likely to go to the competition? This is pretty important, right? So nowadays there are a lot of options available as a consumer, right? Then why should he stay with your product, or why should he stay with your service, right? Because he has a lot of options. If they feel any one bad experience can make you lose a customer, right? Say for example, if somebody is tweeting bad about a particular product, right? So if you come to know about the customer experience immediately, you can reach out to the customer and then you can try to solve his problem, so that he will be happy that his problem has been addressed and he will try to stay with you. So if you just leave it as such, right, then he's obviously going to convert into a different competition's customer, right? So that's where the real-time analytics all come into play. So nowadays businesses wants to get the insights real time. They really don't want to wait for a batch process and know about what the customer is experiencing after 1 month of time. So some bad experience happens at certain point of time. They want to perform real time analytics and they want to address the customer immediately. Just imagine like somebody is tweeting bad about your product hashtag and then he's telling something in the Twitter. Automatically the Twitter feeds with the company hashtag goes into a certain real-time application, and then it goes into a certain algorithm, and then it just identifies that particular tweet as a positive sentiment or a negative sentiment depending upon the type of the words the customer is using in the tweet. And then it will send it to the respective support analyst. If it is a bad sentiment, it will send it to a certain support analyst, and then the analyst can reach out to the customer individually and then ask his concern, address the problem right away, so that you can retain your customer in your business. So analytics, data analytics, real-time analytics, all those things are really paying off with these type of use cases where you are able to retain your customers, right? So what impact will new products or services have on revenue and margins? So whenever the company wants to launch a new project, then they can project their revenue depending on the other projects, other products performance. So those type of questions they will have answer, right? Then you will be able to support your data with the current products and services performance, and they can project something on what they will expect when they launch this new project, right? Those type of questions can be answered by analyzing your past data. And then what product promotions have the biggest impact on revenue, right? So basically you want to figure out what products are doing well and what products are not doing well. So if you have a promotional budget to spend on promoting your products, so basically you have to concentrate on the products which are not doing well, because certain products don't need promotion. They're already popular and people are already buying it. You don't have to waste your promotional budget money on those type of products. So if you come to know like what kind of products are still doing better and what kind of products are not doing better, you can make informed decision on promoting the product which is not doing well, so that you can improvise the business on that and you can effectively spend your budget on certain areas to derive maximum value, right? Then what is the most effective distribution channel? It's pretty important. So there are a lot of ways you can reach out to the customer nowadays. The customer can come to your website, or you can send email to the customer, or you'll be using social media. So which is the best way to reach out to your customers is very important, right? If you're sending a post, and then you can just track now like how many people are reading your post and how many people are if the customer opens your email or not, you're able to derive the value. Say for example, they usually send a pixel attached to the email, and then if a customer opens, then they will know that whether the customer has opened the email or not. To that level of intelligence we'll be able to get from the distribution channels. So you can figure out, say for example, you are always sending out like print mails to the customer, right? That is one of the biggest expense of the company, because if you have like millions of customers, as per the regulations, the bank or any other business has to send them paper mails, right? So basically nowadays people have access to social media and then emails and everything. So the paper mail is an expensive affair. So they have to print the letters, and then postage costs and everything is going to be costing big time for the company. So the company will always try to figure out ways to encourage the customer to move to one of their digital platforms, so it will save a huge amount of money. So they will encourage you to sign up for their paperless statements and everything, right? So they will figure out what sorts of customers are using digital way of communication, and what kind of customers are you still using paper, and they can focus on that certain area of customers and then try to onboard them into a digital platform, or make them access the online banking website to get their statements or whatever. they can achieve that, if they can transform the customers from the paper platform into a digital platform, it's going to save a huge amount of money for the company with respect to the postage and as well as your printing costs, right? So these are the this will give you a very good idea about why do we need to consolidate a data. We have also touched upon the data analytics in this slide. Even though we are talking about data warehouse usage, we have also touched upon how data analytics is going to help you out when you have a proper data warehouse, right? Hope this gives you a good idea of variety of use cases where the data warehouse can be useful. So we slightly touched upon OLTP versus OLAP. To reiterate that concept, let's try to understand the difference. So like I said, OLTP is online transaction processing and OLAP is online analytical processing. So in OLTP, there are many short transactions, queries or updates, because like whenever a transaction is performed, it's going to be an individual customer level transaction. So it's going to be updating one or two records in the application, right? Say for example, it's updating an account balance or enrolling in a course or add a booking to a shopping cart. And these kind of examples belong to a short transaction category. The queries will touch only small amount of data, probably one or two records. That's it. And then updates will happen very frequently because transactions will happen like very frequently, right? And then concurrency is the biggest performance concern. So you have to make sure your platform of OLTP is built for concurrency. So if there is a problem with respect to concurrency, if concurrent users perform transactions, if your database is not performing better, then that's the biggest concern. You have to make sure your database is performing well for concurrent transactions. That's OLTP. Moving on to OLAP, which is our primary area of focus. Long transactions and complex queries. So if you run a query in a OLAP environment, probably you'll be joining with one fact table with the 4 or 5 dimension tables, and then it will be like churning out a lot of data in the background in order to bring you the query response, right? So what kind of example? What's the report total sales for each department in each month? So you'll be like grouping by each department and grouping by date, and then figuring out the sum of your total sales, whatever, and then it will bring you the entire aggregated view of the total sales for each month for each department. So it's going to touch a lot of data in the background. You have to identify the top selling books. Then it has to figure out the entire data platform to get you the top selling books. Count classes with fewer than 10 students. You can write logic and it's going to churn out. So the queries touch large amounts of data in the background, right? And then updates are infrequent. So normally we don't update the OLAP environment like we do in OLTP. So probably OLAP environment will mostly batch processing update, where at the end of the day, you'll offload all the data from your online transaction platform into a OLAP platform in a nightly batch process. In the nightly batch process, when you apply your updates, you will either do a update the record in place, or you will update the record and maintain the history of the record. That's where we call about like SCD type 1 or type 2 kind of a transaction. So type 1 meaning like there is no history maintained. There are few tables where you don't have to maintain history, then they can design it as a type 1 table. Type 1 table is nothing but the records are updated in place, the history is not maintained. Type 2, there are like more type 3, type 4 and all, but most of the times we'll be stopping with SCD type 1 and type 2. Type 2 is a scenario where you will retain the history. Say for example, customer A has an address of 123 street, and then he is updating the address to like 456 street, right? So what will happen? The 123 street record will be end dated, and then the active indicator is another column which will be changed to no, so that it is not active anymore. And then we'll insert a new record with a new date, new active date, and then you will mention the active indicator is Y. This is an example where you will maintain the history. Say for example, anytime you want to find out the latest address of the customer, you can go by the active indicator and get the latest record. And anytime if you want to find out what are all the addresses the customer has stayed, then you can go by the customer ID and then query the table. It will give you all the rows in which the customer resides, all the addresses the customer resided. You'll be able to pull them. So that's how you will update your data warehouse, right? This is the primary difference between OLTP and OLAP. It's very critical for you to understand the differences between these two platforms. So moving on to data lake. So far we have covered all the concepts about data warehouse. It's very important to understand the basics of data warehouse. Even though you are going to move into data lake, you have to understand the basics of data warehouse so that you can differentiate between those two depending on what type of application you develop, right? So data lake is the new age concept where everybody is moving to a data lake environment instead of data warehouse environment because of its own advantages. Let's see what's data lake and what are the advantages. So this is a data lake. So data lake is like a one big lake kind of an area where you can dump all sorts of data into that, and then you can have that as a single point of storage, and then you'll be able to run your on-premise data movement gets into data lake. Real-time data you can put into data lake, machine learning and analytics, whatever the data you are trying to explore, you can put everything into data lake and then you can use it from there. So a data lake is a centralized repository that allows you to store all your structured and unstructured data at any scale. So at any scale, infinite amount of storage is available nowadays, especially with cloud computing and Hadoop and everything in place. Storage is becoming a very cheaper affair. So you can just dump whatever the record you want to dump into your data lake. And if you, the main advantage of going into data lake is like you can dump structured or unstructured or semi-structured audio files, video files, anything can be dumped into a data lake and you can derive value out of it. So you can store your data as is without having to first structure the data. The main disadvantages of using a data warehouse is you have to bring your data into a structure before you can store it into a data warehouse. You have to bring your data from disparate data sources into a certain data model so that you can insert it into your data warehouse. Most of your time will be spent on designing your data warehouse in a certain format and then bringing your source data into a acceptable format into your data warehouse. On the contrary, in data lake scenario, you can store the data as is. You don't have to worry about structuring the data or whatever the format you get from the source system, just bring it and dump it into your data lake. That saves a lot of time. And you can run different types of analytics, from dashboards to visualizations to big data processing, real-time analytics, machine learning. So whatever the use case you can think of, you can point it to your data lake and you have an option to run it. So that's the primary advantages of moving to a data lake. So why organizations are moving to a data lake concept from a data warehousing environment, right? So organizations that successfully generate business value from their data will outperform their peers. So why the companies are doing data analytics in first place, right? So because the competitors are doing it, right? So if you are not doing it, your competitor is going to do it and he's going to outperform you in the business and you'll be like maybe bankrupt if you don't really follow the market trend of, keeping up with your customers' requirements and needs and everything. So automatically, if my competition is doing data analytics and then he's using a data lake and then he's able to derive insights faster and then he's able to bring new features into the product quicker, then I am also forced to get into the same technology with the new age applications, with the new age options available. Companies are moving from a data warehouse environment into a data lake concept. This data lake enables us to do new types of analytics, right? Like machine learning. And then if you have log files, you can do log file processing. Log file is a great resource. Log file is something, if you just look at it in a raw form, you cannot figure out anything about it. But when you are able to parse the log file, it will give you a lot of information. So for example, if a customer is getting into your website and then you can, if all those activity of the customer is getting into the log file, right? By analyzing the log file, you can pretty much track the customer activity, like what he is doing and which page he is spending more time, which page he is spending less time, then what type of customers are using which type of products. All those kind of things you can derive from a log file. But if it is in a raw form, if you are using a data warehouse, there is no way that you can bring it into a data warehouse data model and then deriving analytics out of it is going to be unimaginable. But if you're using a data lake, you can dump the log file into the data lake and you can use the new age applications tools which can parse the log files and then it can give you insights very quick. It's going to be very helpful. And then data from click streams, depending on what kind of clicks a customer is doing in a website. And then social media and internet connected devices. Like say, for example, I was talking about the Twitter example, right? When somebody is tweeting bad about your product and then it can just stream into the data lake. And then from the data lake, you can do your algorithm sitting on top of it to find out the bad sentiment of the customer. And then you can figure out the problem and address it immediately, right? Internet connected devices like social media, tweets and everything that you can just real time stream into your data lake. You don't have to worry about, formatting the data or like storage concerns or whatever. So that's the great advantage data lake brings into the game. And then the data lake helps the business to identify and act upon opportunities for business growth faster by attracting and retaining customers, boosting productivity, proactively maintaining devices and making informed decisions. So it'll enable the business to act fast, right? What kind of business areas we can focus on growth? How can we attract and retain the customers? How do we boost your productivity? So all these types of, and then you can run some machine learning, and then you can do some descriptive analytics based on what is the past products performance. You can do predictive analytics based on like how it will perform in future. There are a lot of new age tools available which can sit directly on top of your data lake, and then you can perform any type of operations, right? So what are the primary differences between data warehouse and data lake, right? So data warehouse is more of a structured process environment. So you have to bring the data into a structure in order to derive your insight. But on the data lake's point of view, structured or semi-structured, like JSON formats or XML formats or whatever you have, a semi-structured data, unstructured data like audio or video files or whatever you have, you can bring it into a data lake with respect to the data. With respect to processing, data warehouse sits on a concept of schema on write. Schema on write meaning you have to bring your data into a certain schema format in order to make an entry into your tables in data warehouse. But in case of data lake, you really don't have to be bring your data into a certain format. You can just dump the data into your data lake as is, and then when you read the data, you can worry about the schema and everything. So that's why it's called schema on read. It's more flexible. Basically, you can ingest all the data you want, and then you can worry about the schema when you read it, right? That's very useful feature. And then data warehouse usually follows a hierarchy, but in the case of data lake, it's object based storage, so there is no hierarchy. Each object is individually stored into their own location. And then data warehouse is obviously less agile, and then it has a fixed configuration. You cannot really bring in new changes immediately. So if you make any changes to a column in a table, right, it will trigger a lot of changes to your ETL jobs. You have to change a lot of processes and everything in order to implement even adding a single column to a table. You have to go through a lot of effort. It's not really a very agile environment to make any changes to data warehouse. But in case of data lake, it's very, very agile. So you can make any change. The source system can change the data type at any time, and really don't have to worry about changing any of our code, because I'm working on a concept of schema and read. So whatever the format the source system is going to put or dump the data, I will take care of it when I'm reading, because there are a lot of new age tools available which can actually just read the data and understand the data structure, and it can create the table for you. There is something called crawler concept in AWS. So if you just dump a file into S3, S3 is a storage in AWS like HDFS and Hadoop, right? We'll talk about those concepts later. So basically, you can dump a file into a storage area, and then you can write a crawler which will go and read the location. It will be able to automatically identify what is the data type, and then if there is any header in the data, it will understand. It will create a table with whatever it is able to understand without any manual intervention. The data dumped into a storage area will become a table in minutes. So it is very, very agile, and then you can configure and reconfigure your metadata as needed, right? And with respect to security, it's very data warehouse is a very mature environment. Basically, it has been in use from 1970s, so it's been it has guidelines, it has like everything defined and matured in a data warehouse. But data lake is still maturing, so it's a new age concept. So there are like a lot of features getting added every day, and if there is any problems, they are addressing it on the fly. So basically, it's still a maturing environment, but it's the future. So everybody will be working on data lake in future. Any new applications will be built on data lake. They won't be going to data warehouse. And anywhere, any customers who is using data warehouse are definitely going to move into data lake, right? It's just a matter of time. And who are the users for your data warehouse? Business professionals, like who can go and run some reports, like what is the 13-month trend of this product? What is the reports? There will be like predefined set of reports will be there, and then they'll go and run it on a daily basis or a weekly basis and monthly basis, and then get some insights about it. But in case of data lake is more agile, and then data scientists can go and run their algorithms, and then they can derive values out of it. It's more like a new age platform where like they can do descriptive analytics, predictive analytics, machine learning, or even a typical structured batch processing. Whatever you want to do, you'll be able to do using the data lake environment, right? So data lake is going to be the future. So now in this particular video, we have covered you about some basic concepts of data warehouse. Don't think that since data lake is going to take over, I really don't care about data warehouse anymore. It's not like that. You need to understand data warehouse so that we can work efficiently on a data lake. And then most of the cases, the projects will be like transitioning from data warehouse to a data lake environment. So you have to understand both sides of the picture in order to efficiently transform into data lake. Or if they are a new application, they're going to start with data lake to take advantage of the new age tools, right? So in this video, we try to give you some basic idea about data warehouse and data lake, which we think it will be useful to get the foundation ready to understand these concepts. So that's all I have for this video. We will make further videos with more concepts, and looking forward to get some feedback from you guys. Thank you.